Well, this is tonight's Randomizer. I'm Charles Schultz from Schultz Laboratories and Universe Science Center. And tonight's subject is something a little different. The subject for this evening is C. It's not the letter, it is the language. This is all about the programming language C, and I think you're going to find this to be a fascinating discussion, actually. And I know that most people are not programmers. And years ago, when I started doing this, there were very few programmers in the world. It's become a lot more popular in these days because computers are very pervasive. They're everywhere, and everything runs on a computer. But I'm going to assume that most of the listeners and watchers are not programmers, and we'll go from there. First of all, I would encourage you all to go to schultzlaboratories.com or universesciencecenter.com. Go to the site. Join our Monday night classes at 9 p.m. Eastern Standard Time, or become a member of Schultz Laboratories or Universe Science Center and support our growth in addition of additional 3D virtual world sites, galleries, and content. We've got just about everything in there. And it's going to get larger, and with your suggestions and support, we'll add more subjects, more material, and more fascinating things for you to do. So on with the discussion of C. Now, people know that there are a lot of programming languages, although they're generally not familiar with them. Back in the early age of computers, there were only a handful of languages, and Fortran and COBOL were two of the big ones, and they're even still around today because they're just so useful. At the same time, right around 1960, there was a language called APL. Now, it sounds like a technical name, but APL meant a programming language. Now, the advantage of this language was that it had, it had a lot of power, and it had very concise instructions. The problem is, while there were many, many symbols involved, it made it easy to write a statement. You didn't have to do a lot of typing to get your idea across. But the proliferation of symbols made the code short at the expense of often needing a specialty keyboard. But it was a good language. And I worked on a couple of machines many years ago when I was in aerospace that ran on APL, and they had those specialty keyboards. So you had like 3 or 4 extra symbols on a lot of the keys, and you'd shift this and shift that to get those symbols. But it was an okay language. It did a lot. From there was a language that took a lot from it called BCPL, and that was in 1966. And BCPL was like an enhancement. And one of the things that really came out of APL was multidimensional arrays. Places like a post office box where you had an X and a Y, and you could put a lot of numbers in there, and with one stroke you could calculate a lot of stuff. So it had a lot of power. BCPL in 1966 was like the progenitor to the B language. Now, B was written in 1969 at Bell Labs, and Bell Labs was a research organization. Many people know Bell Telephone long before all of the phone systems that we have existed. Bell was like the giant, and it was named after Alexander Graham Bell. But Bell Labs did a lot of research projects, and they supported a lot of learning and research, and it was a really cool place for many people to work. The B language came into existence in 1969 at Bell Labs, and it was written by a couple of guys, Ken Thompson and Dennis Ritchie. Now, that name is going to be very important here. An enhanced version of B was written by Dennis Ritchie called C, and this is the subject, C. Now, what's important about programming languages? Well, we communicate with computers and we control them, but let me explain something. Normal language is basically descriptive or declarative. You can write a book with it. You can write a note on your refrigerator. You can make a grocery list. You can pass instructions to someone. But a programming language is entirely different. Programming is dynamic. And the easiest way to make this clear, in my opinion, is to say that a program is a living embodiment of your will. You take a plan, you formulate the plan, you put in your information, you hook it to a system, and you run it. And it comes to life. And it executes the decisions that you, under those circumstances, have decided would be made. So a program is an embodiment of your will, not just a written statement of something. And this is very important because your ideas can come to life in hardware. And this is a fundamental issue. in automation and robotics. And I did many, many years of automation and diagnostics and systems. I worked aerospace and defense for over a decade. And I had a great time working on all sorts of computers. But in the early 80s, about 83 or 84, I first came across C, and I loved the language instantly. It was an amazing thing. The C language was described in a book in great detail called The C Programming Language, written by Brian Kernighan and Dennis Ritchie, the author of B as well, in 1978. And if you ever want to learn about C, that's the book to get. You can get them used online on eBay or Amazon for $7 or $8. And I'll tell you, it's well worth it. If you learn any languages, I would definitely recommend C and Python right away. Now, why C? Because C is it's in a middle ground. We talk about languages, programming languages, and we talk about a low-level language. A low-level language is like assembler. It is a language that speaks to the bits and hardware in the computer. You have utter and absolute godlike control over what happens in that machine with a low-level language like assembly. When you talk about a high-level language, that would be something like Python or BASIC, for example, or Ruby. In a high-level language, you have a statement like print that makes many, many things happen. There are libraries of functions that people write to add to languages. And those libraries mean you don't have to write the same function over and over to get to do a certain task. C is a moderate level language. It's a mid-level language. Some people call it a high-level language, and it does have a lot of high-level functions. But understand that C will actually allow you to code assembler in it in many cases. So if you know assembler and you know C, you can take absolute control of your machine by writing very low-level detailed hardware-related instructions or moderate to high-level functions. And you have libraries of those instructions available for your use. You simply import them into C and you run with them. You've just added a whole schwack of new commands to it. So this makes C very flexible. When the language was written, when the core of the language was first created and the compiler that writes the code and turns it into actual working software, they wrote the rest of the language in C. So the C language is really written in C in many cases, and it's sort of a self-bootstrapping situation. That sounds crazy, but it's also a story worth reading. Why do I like C? Wow. I started out with Turbo C about 1983 or 84, and I found that I could do anything in the world on a standard PC, and they had IBM PCs back then. And it was, for me, a solution. I could get right down to the hardware and do things. Today, I persist with C for a number of reasons, and I'll show you in just a moment. I do a lot of robotics and creating, and I have boxes of processors that I use when I'm building these things. And so these are Arduinos, and it's a type of little processor card that can do a lot of functions for you very simply and very cheaply. You might spend $15, $20, $30 on one of these. The Arduino processor is like this, and you'll notice there's a lot of plugs on the edges. Well, you can literally drop a color touch screen on top of this thing, and it turns into a device very similar to a cell phone, without the transmitter, of course. But what it can do for you, you write a program in here, and this thing has lots of input and output terminals that you can use to control things like communications, light dimming, turn relays and switches on and off. You can read thermal sensors and battery charge level. You can do anything with this device. It is a very general purpose sort of machine. And when you buy one, you have a little cable that comes with it, and you can plug it right into the edge of the card, just like this, and it goes into your USB port on your computer, your laptop, your desktop, it doesn't care. And you can write your code on your computer, and it downloads right into a flash memory in here, so it won't forget it. And then for years to come, that program will be in there, ready for you to use at a moment's notice. Now, how do you do something useful with a little program in C on this piece of hardware? Well, that's actually carried out very easily by the use of what's known as a relay card. So you can buy a module that has relays in it, and we'll talk about that in a second. Let me show you what this thing looks like. This is a circuit board that you plug into that little card that I showed you. This board has 16 relays on it, and by simply plugging a cable and running a little code on this thing, you can turn any one of these relays on or off. And a relay is like a switch. It's just like the light switch on your wall. And what this device does is it allows your computer to turn on and off lamps, motors, sensors, all sorts of devices with almost no effort. So these things cost like $20, you know. So you can do a lot of fascinating things if you're into robotics or automation. If you have a hydroponics greenhouse, you can use this device and that processor and a little bit of code in C, and you can turn on and off your pumps, your lighting, your heating, open the flaps on the windows, whatever you need to do with very little effort. And I do mention from time to time, I'm going to start a robotics course and teach people how to do these things. Well, these are some of the devices we're going to be looking at. So the C language, I really enjoy programming in C. These boards use a tiny set of C, a subset, and they'll do programming functions like calculations, delays, timers. You can write things that will format a message in serial code and send it out to another device and read back from that device with, again, very little effort. So the C language is one of those things that's come along, and because of the way it was written, and because of the fact that you can import a library from any machine, it became exceptionally popular. And I don't imagine there's a whole lot of devices on the planet that you can't find a version of C that will run on. You can even download on your cell phone. I have I have a programming package on my cell phone that allows us to do Python and to program C and to do automation. So it's just like the universal glue that binds a lot of robotics and automation and app systems together. So there's a lot to know about C, and you can take it as far as you want. There are C++, C++, C#. There are more and more advanced versions of it available. And you know, I look back pretty fondly. The first version that I learned was Turbo C on an old IBM XT computer that ran at a blazing 10 megahertz. My laptop runs at what? About 2.5 gigahertz, 8 cores. So you're looking at like about 40 gigahertz, 20 gigahertz or so effective processing speed. So if you stop and think about the changes in computing from 10 megahertz to like 20 gigahertz, it's like 20,000 times faster than the computers we had in 1983 and 84, which is really amazing when you stop and think about it, how quickly it has progressed. So at this point, I'm just going to say, I do recommend the C language, and it's one of my favorites. If you're going to learn programming languages, and I think that I've learned probably 50 or 60 languages over the course of time in programming alone, but I do highly recommend C and Python. Python for AI work mostly because it's extremely flexible and it supports computer vision processing and a lot of other things as well. So C is a great place to start if you want to learn about programming. And definitely we're going to be using it when I start teaching robotics classes to everyone. And you know, stay tuned to this channel, they say. Well, keep your eyes on what we're doing at Schultz Laboratories and Universe Science Center. We will be teaching you how to build robots very shortly. If you're interested, we're not going to force it on you. Do go to the page, schultzlaboratories.com or universesciencecenter.com. Sign up for our Monday evening classes, 9 p.m. Eastern Standard Time. We're going through the Meta World series right now about our advancement from sticks and fire to nanotechnology, how humanity's intellectual growth and technical growth is progressing and why it took so long and where we're going next. We're going to actually talk about how we can create synthetic worlds and make doorways to get in and out of those synthetic worlds. These are things that are coming our way so fast. It's amazing. And I just hope that everybody remembers that each and every one of us kind of has a responsibility to try and make life better. You know, we don't have to do big things. Small tasks will help. pick up a little litter, throw it in a can, doesn't hurt us. You see something wrong, try and fix it, and just be a good person. Share your experiences with us, and come and share your opinions, ask questions. We're glad to help in any way we can. Now, if we have any questions from here we are. If we have any questions from anybody who's in the meeting right now, I am encouraging you to ask them now, and we'll answer them. And by the way, if you work with these boards, the Arduinos I showed you, there's also another very popular card series called the Raspberry Pi series. They also support C, among other things. And believe it or not, the same power you have in a laptop computer is now available on cards that will fit literally in the palm of your hand, small as a credit card or smaller. When you stop and think about it, we're almost to the point where we can embed incredible intelligence, video processing, image processing, software capabilities in something as small as a bug. And that's terrifying in some ways, because that means something as small as a bug can do anything. But in the other ways, you look at it, when we get down to really useful automation systems, and one of the things we might see in the near future, and these are being developed now, is robots as small as bugs that literally kill insects on your crops. You talk about something that's very cool. These little guys can be solar powered, and they'll never use any insecticide, and they could get pests off of your crops without a single drop of poison. Now that's kind of interesting. We have within our grasp the ability to make technologies that will literally transform our world in a positive way. Learn about these things. You'll be fascinated if you can apply your expertise to something like that. We all need to know that our efforts are making the world better, that our work is yielding something positive. Well, I see you don't have any questions, and nobody's put forth any ideas. At this point, I think I'm going to call it, and I appreciate everybody showing up for these talks. And again, become a supporter, get your Oculus, walk around in our galleries in the Universe Science Center, and just enjoy it. And give me some feedback. We're going to install the phone line so you can call in if you don't listen to this online, and we can take direct phone calls very shortly. We got the hardware, and it's just a matter of hooking it up at this point. Well, thank you for everybody showing up tonight. I do appreciate it. And we will have another randomizer tomorrow, 6 p.m. Eastern Standard Time. We're looking forward to you being there and participating. Thank you from Schultz Laboratories and Universe Science Center, and have a great evening.